Hang on, say that again.
I mean, 2 of them are gonna be white, and the rest of them are gonna be black. I mean, 2 of them are gonna be black, and the rest of them are gonna be white.
So if they had, wait, they had 6 babies.
Yeah.
According to this, hang on, I'm with Richland.
6.
I'm with Richland. If 50% were going to be white and 50% were going to be black, and they had 6 babies,
Yeah.
tell me what you would expect.
What?
If also, you told me
Yeah.
that 50% of the offspring would be white and 50% would be black.
Yeah.
The sheep have 6 babies. What would you expect?
I would expect the half them to be
How many?
6 divided by 2. Oh shoot! I get it now. I'm sorry. I realized my mistake. That okay.
Yeah. You got this. You got this.
Yeah. It's gonna be a fraction. Now it's gonna be 2 point. It's not gonna be like I get it now. I understand. I understand. Yeah. It's 3 and then yeah.
These are sheep. Richland.
Yeah.
Okay, help me out here. These are the sheep. How many of them should I color in because they're black?
3 of them.
Thank you. Okay. Problem solved. Okay, so Richley is expecting that 50% of the sheep are going to be black. The problem is telling us that 2 of them are black. Choose. Can you explain what you had just said a minute ago?
It's the prediction that they have to outcome, so it doesn't really matter.
Yeah, so that's great. You want to add to that?
Yeah, so like the main thing here is that you know that one of the parent sheep is going to be white and one of the other one's going to be black. So because of that, you want to have a higher probability that to have half of the sheep be black. So
What do you mean a higher probability that half of the
so
sheep?
50% of the sheep should be black, but the thing is, in actuality, only like 30, is it 30? It's a 2 to 1 ratio, so 33.
Yeah. Yeah.
Were black. So the problem, I think what was confusing Richard is like, or like other people, I guess, is that because if they never mention anything about like their parents, you would expect the result to be 2 heterozygous parents. But you can't. That is true. Like that can actually happen, but it's higher. It's better to have a higher probability of there being an equal amount. So like 50-50 chance. But the key thing is that they give the parents.
I agree, that was the key thing. And I would say that when this was on the MCAS, and I know we're dealing with an MCAS problem, we haven't yet like launched ourselves into like AP level questions. That was the thing that tripped out most people is they would read the question and whip out a Punnett square and ignore the parents.
Yeah,
Phenotype,
also
which is the problem.
25% is much closer to 33
Yes.
than 50 is, and it's literally just the parents, and then better to have a higher chance. Because I know this tripped me up when I was explaining it on the day.
So let's continue to think though about how the observation of the actual offspring does not match our prediction and why that is. So we're gonna go in this order. Boom, 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 boom. boom.
I just want to blow my nose. I just want to blow
Go
my nose.
for it. Miriam.
So it's probability, so it doesn't always have to follow probability. Like, say there's a 50% chance, like you're flipping a coin, right? 50% chance tips. It's not, it could, like, if you flip it twice in a row, it could be, like, heads, heads. It doesn't always have to be, like, heads, tails, heads, tails.
Yeah.
You don't always have to follow the probability. It can be different sometimes.
All right, great. I have a follow-up question on that, but I want to get some other people's thoughts.
Yeah, I just wanted to say that nature isn't perfect, and for every baby, there's a 50% chance it'll be black and a 50% chance.
Oh, I like that you said that. That was actually my follow-up question. So the sheep are about to have their first baby. What is the percent chance that it's going to be black? They're about to have a second baby. Does the percent chance it's going to be black change?
No.
No. So keep that in mind. Thanks for saying that. Jamiris.
Basically, there's just a way I was going to say, but I was going to say that the fact that there's a dominant phenotype actually part of the fact, the reason why the ratio has changed a little bit.
Oh, that's an interesting thought. Did everyone hear what Jamiris just said? Can you say that one more time, and I want us to...
I was basically saying that I was, like, it's predicted to be 50-50. The thing is, like, the fact that there's a dominant phenotype might affect the reason why the white is going to be higher than black.
Agree? Disagree?
I agree with that.
I'm glad you did. So Jamiris, let me to restate. He's saying that even though there's a 50-50 chance, because white is dominant, that is going to make even more white offspring than the Punnett square predicts. Priscilla.
I think I'd push back on that a little bit because I don't think that the fact that it's dominant automatically makes it like more able to like reach your genes. You know what I'm trying to say? Like it won't like it's not more likely that the dominant gene will like show up in your genes, but I think like what Jeremiah was thinking that maybe because dominant, like it doesn't take much for it to show up in your genes. Like it takes a little bit more, technically speaking, for the recessive phenotype to show, to show up in your bodies or whatever in the sheep's wool, because you have to have true recessive genes, whereas for the dominant trait to show up in this phenotype, like you only need one. So I understand where Brian's coming from, but I don't think that the fact that it's a dominant makes it more likely to show.
Did I point to somebody back here and then skip them?
Yeah, it was me,
DJ?
but I mean, my thought was taken. So.
Oh, I'm so sorry. Well, it's good now. You've confirmed it. And did I miss anybody back over here?
I don't know my nose.
Okay. Rachel.
Alright. I agree with what you guys said, but I feel you guys are talking about predictions. We have numbers, they're not predictions. I feel like they give us the number of babies being like this already happened. We're just predicting, like, I don't know. I feel like it's still wrong. I don't believe it. It's still wrong.
So,
I don't.
what would make you feel better about it?
If they give us the parents, because like if you do it again and both parents were hetero guys dominant, then the numbers would match. It would have been the same.
Oh, okay. So yes, if the parents were heterozygous, then that would have made perfect
It would
sense.
make perfect sense because you get 1/3 of the babies will have black wool and 2/3 of the babies will have white wool.
Yeah, but that's not the problem. Like the parents really are one white, one black, and yeah, so that's not something we get to change. Gisela.
Well, I wanted to answer, I guess, like Jamar's question. I think that like you don't necessarily have a higher chance of like having the white gene just because of like the dominant allele, but I think that you're more likely to have that gene type in a sense, like be passed on. So like if you look at like brown eyes, they're constantly like everyone in this room basically has brown eyes except for like Rebecca and Shannon. But then and Elizabeth.
So wait, okay, whatever. So you're saying that the dominant allele is more frequently passed on to the gametes
yeah, I feel like that's
than the recessive allele. That is an interesting thought.
I feel like it is
Oh.
in cases.
Do you know like what's behind your thinking?
Well, my family and my problem with
So you're still mad about not having blue eyes?
Yeah.
Okay. Oh my god.
You want to write it down,
Alright, so
I have a question for Joe.
thank you. So here's the deal, folks. I know we're still doing the do now, and that's okay. This is an awesome conversation, so we're gonna keep going with this because more people have some thoughts. And then once we have sort of wrapped up this conversation, I have some more practice for you to do. And I think we're actually gonna skip right to a more challenging question because you guys seem ready for it. We're gonna go with Zuri, Priscilla.
So the question for the do now was to predict the genotypes of parents, correct?
Yeah.
What is this whole conversation about? 'Cause I'm so confused.
This conversation is about Ridgely's and other people's discomfort that we predicted
Discomfort.
from the parents, and these are the correct parents, that it would be 50% white babies and 50% black babies. That is not what the question says.
Well, that's not always gonna happen. It's a prediction. So like, there you go. I mean, like,
So you're ready to move on. You're like, ready to prediction.
stop it.
So-
Stop.
Respond to Gisela, and then I have a follow-up question.
I was gonna respond to Richly because I want to help my friend.
Go
So,
for it.
so on the MCAS, we're always gonna try to trip you up, and like this is one of those examples where they're like, oh, 4 of them are gonna be what? Well, huh? I'm just helping you try to understand. So you won't get any other questions wrong. Okay. So it's not always gonna happen perfectly like everyone else is saying, and I think the big thing that you have to take away from like the 4 white wool, 2 black wool thing is that some of them are gonna be black and some are gonna be blue. So,
Boom.
I'm not confused.
You're allergic
if it's wrong.
well, I'm helping you, not taking it.
It's Richly, Priscilla.
I think
So let's address this. Here we go. I'm gonna introduce like another thought, and we're not gonna move on yet because this is great. Let's talk about sample size.